part 1 of our lesson on applications of right triangles, you're going to learn how to work with bearing given as a single degree measure. So we're going to work through several examples where we go through these 4 short steps. So let's get right into it. We have to make a sketch for each situation, and in this first example, the bearing is 37 degrees. So step number 1 says to make a starting point. Step number 2, from the starting point, draw a dotted line to the north. Now we know that on a map, north is at the top of the page, south is at the bottom, east is to the right, west is to the left. So we'll use that convention. So from our point here, we draw our dotted line to the north. We're all ready to step 3. From the dotted line, draw a curved arrow traveling clockwise to indicate the rotation of the angle, and then label the degree measure along the curved rotation arrow. So from the dotted line, we have to go clockwise 37 degrees. So that would be about here. Step 4 says from the starting point, draw a ray that passes through the end point of your curved rotation arrow. So here we have it. Go from the starting point through the end point of our curved arrow. This ray is the bearing. So this ray is your answer. In this next example, we're told that the bearing is 317 degrees. So why don't you try this one on your own? Pause the video and then restart it when you're ready to check your answer. We work our way through the 4 steps. So step 1 says make a starting point. Step 2, draw the dotted line to the north. Step 3, from the dotted line, draw a curved arrow traveling clockwise to indicate the rotation. Now, if this is 0, then that means over here would be 90 degrees, down here would be 180 degrees, over here to the left would be 270 degrees, so 317 we know is going to be more than 270, but less than 360. So we know this rotation will look something like that. And we're ready to draw in the ray. And there's our bearing of 317 degrees. In this example, we have to make a sketch where the bearing from point X to point Y is 260 degrees and their distance is 15 miles. So we walk through the 4 steps. Step 1, make a starting point. And in this case, it will matter whether we call it point X or point Y. And the bearing, we're told, is measured from point X. So because it's from point X, that means our starting point is X. Step 2, draw the dotted line to the north. That's our 0, our starting bearing. Step 3, we have to make a curved arrow indicating the rotation of 260 degrees. Now we know this would be 90, this would be 180, this would be 270, so we're a little less than 270. So 260 degrees. Step 4 says we'll draw a ray from our starting point through the end point of our curved arrow, and that's our bearing. We know that our bearing is looking at point Y, so we need to come to the end of the bearing here and call that point Y. And then the distance between those 2 points is 15 miles. In the next example, we have to make a sketch where a ship travels from point P to point Q at 18 miles per hour on a bearing of 153 degrees for 2.5 hours. So go ahead, pause the video, try this one on your own, and then restart the video when you're ready to check your answer. Step 1, make our starting point. And because we're measuring from point P, we know we have to call it P. Step 2, draw the dotted line to the north. Step 3, draw our curved arrow indicating the 153 degrees. So we know this would be 90, this would be 180, so we have to be in between those two. Step 4, draw the ray from our starting point through the end point of our curved rotation arrow. We know that the bearing is looking towards point Q, so we make a point there and call it Q. And now we can figure out the distance between those 2 points by using the fact that it's traveling 18 miles per hour for 2.5 hours. Now we know from our Algebra 1 class that distance is equal to the rate times the time. So the ship was traveling 18 miles per hour, and the time was 2.5 hours. So I think I'll write the 2.5 hours as an improper fraction. 2 times 2 is 4, plus 1 is 5. So we know this would be the same as 5/2 hours, and I'll bring that over here into my distance equation. 2 goes into 18 9 times. 9 times 5 is 45. Now when we look at our units, the hours in the denominator will cancel with the hours in the numerator, and we are left with miles. So we can put that on our picture. So for this example, we have a word problem that involves 3 radar stations, which we'll call A, B, and C. Let's check your understanding. So pause the video, work the example on your own, then restart the video to check your answer. Now, radar station A is 10 miles due west of radar station B. So A could be over here, and B would be here, and we know that the distance between them is going to be 10 miles. Next, we're told that the bearing from station A to station C is 74 degrees. The bearing is from station A, so we know that means our dotted line has to emanate from station A going north. We're going to rotate through an angle of 74 degrees. And we can put in the ray that represents the bearing. Now, we don't really know how long to draw this ray, but we know that C, station C, lives somewhere along this ray. Since we don't know the distance, we don't really know where. C could live here, or it could live here, or here, or here, or here, or here. We just know that if you're standing at station A and you're looking in this direction, you're looking towards station C. So we'll just put a little note to ourselves that that's to station C, but we don't have a point yet because we don't know how far away it is. The next clue is that the bearing from station B to station C is 344 degrees. So we have to start from B, and we're going to draw our dotted line to the north, and we rotate through 344 degrees. Well, we know that would be 90, 180, 270, 360 would be all the way around, so we back off just a little bit, and we know that is 344 degrees, and we put in the ray that represents the bearing, and we know that that has to be pointing to station C. Well, if this ray has to point to station C, and this ray has to point to station C, then it must mean that station C is where they intersect. Now we can start to find some angles in the triangle, and we certainly hope we're going to end up with a right triangle so we can use SOHCAHTOA, but we don't know that yet. So if we take a look at our drawing, we do know that north is going to be perpendicular to east. So we can put in a perpendicular symbol here. And then we can say that this angle in the triangle is going to be 90 minus 74, which is equal to 16. So we know that this angle in the triangle right here is 16 degrees. Now, over here, we'd like to know what this angle in the triangle is. We know that rotating all the way around to here would be 344 degrees. We know that rotating to here would be 270 degrees. So if we take 344 minus 270, we find out that we have 74 degrees, and that's this angle right here. Now we can use the triangle sum theorem, and we know that 16 plus 74 plus angle C has to equal 180 degrees. 16 plus 74 is 90. So we can see that angle C is going to be 90 degrees, and we're going to get a right triangle. Now that we have a right triangle, we know we can use SOHCAHTOA. The question asks us to find the distance from station C, which is right here, to each of the other two stations. So since this is angle B over here, then we're going to call its opposite side lowercase b. And since this is angle A over here, we'll call its opposite side lowercase a. And now we can use SOHCAHTOA. So to find little side A here, we see that we could use either the 16 degree or the 74 degree. It's your choice. If we use the 16 degree angle, then A is the opposite side and the 10 is the hypotenuse. So that tells us that we're using the sine function. So then we would have that sine of 16 degrees has to equal A over 10. We cross multiply the 10 up to the left hand side and we get 10 times the sine of 16 degrees has to equal A. And now we're going to pick up our calculators, enter 10 times the sine of 16 degrees. We need to close the parenthesis and hit enter. Rounding to the tenths place, we see that A is going to be approximately 2.8. And the units would be the same units as the 10 here, so units are going to be miles. Now to find side B, we can again use whichever angle that we want to. We could use the 74 and use the sine function, or we could use the 16 and use the cosine function. So maybe we'll do that since we just used sine function. So then relative to the 16 degree angle, we know B is the adjacent side, 10 is the hypotenuse, so we're using cosine, and we would say that the cosine of 16 degrees has to equal B divided by 10. Cross multiply up that 10, so now we have 10 times the cosine of 16 degrees has to equal B. And we head on over to our calculator. We're going to enter 10 times the cosine of 16 degrees, close the parenthesis, hit enter, and we see that rounding to the tenths place, we're going to get about 9.6 miles for B. Now, because this is a word problem, we need to write a sentence for our answer. So we can say the distance from station C to station A. Well, let's see on our picture now. From C to A, you have to be careful. You're not using this letter A here. The distance from C to A in our picture is actually letter B, which is 9.6. So in our sentence here, we're going to say the distance from station C to station A is 9.6 miles, and the distance from station C to station B is, well, let's see. From C to B is going to be the letter A that we just found right here, which is 2.8 miles.